Here are those two lines of code again, but instead of the 5, I've just changed the 5 to an x. Now that's perfectly legal because 5 is an integer, as you recall, and so is x. So as long as they're both integers, they're interchangeable. Those lines of code you see in front of you are perfectly legal lines of code. However, they do completely different things. And they are confused so often by beginner programmers that all sorts of bugs result. Let's look at them now. Obviously you are looking at them. Can you tell me what you think each one of them does? Just without referring to anything I've said before, without rewinding this video and trying to remember what it was that I said, can you figure out, just from the use of the ampersand and the use of the asterisk, what's going on? What's the difference? Okay, you can probably read them in English, but what is the actual difference here? What is the difference? Like, what is being set here? These two lines of code do extremely different things. Alright, well, I'll illustrate to you the difference. Let's read them first in English. PTR equals the address of x. In other words, set PTR to point to x, or set PTR to be the address of x. The second line of code reads asterisk PTR equals x. In other words, set the thing that PTR points to be x. Now obviously you wouldn't use those two lines of code next to each other in the same program. You'd use one or you'd use the other. Now I don't know if that is obvious to you, but it's obvious to me. If you're about to write a line of code that does something like this, you'd have to decide which line of code it is that you need. So I'll help you distinguish between them. The first line of code is an initialization of PTR. It actually sets pointer or PTR to point to something. If PTR was already pointing to something, it causes it to point to something else. In this case, it causes it to point to x. In other words, we are adjusting the value of PTR. In other words, again, we're causing PTR to point to something. The second line of code, asterisk PTR equals x, assumes, this is a very, very important but implicit and invisible assumption, the assumption is that PTR already points to something. If it doesn't already point to something, in other words, if PTR has not already been initialized somewhere, this next line of code, the second line of code, will probably cause your program to crash. This says, whatever it is that PTR currently points to, so it obviously must point to something meaningful. If PTR is an integer, then it's obviously pointing to an integer. So the integer that PTR currently points to, set that to be the value of x. Whatever value is currently in x, copy that value into whatever PTR points to, which hopefully means that x is initialized as well, although it's not entirely crucial. If x is not initialized, it's not going to crash the program. If it's not, you'll just get a random number put into whatever PTR points to. But theoretically, x should be initialized as well. Can you see the difference? The first one is an initialization of pointer. It causes that great big yellow arrow that you saw a couple of slides ago to point from one place to another. The arrow might be pointing there. Alright, grab that arrow and make it point over there now. The second example does not adjust the arrow at all. It simply adjusts the contents of the box that the arrow is pointing to. Okay, but I hope I've made that clear. Hopefully now you all have a solid understanding of at least the mechanics of pointers, just what they are. I'll now explain to you why they were invented in the first place. So we know what they are, and now we'll know why they are.